Right. You know, the layer 2 is very easy to form loop. Very easy. The reason is we got many number of ports in a single broadcast domain. If you take a router, each port will be in different network, which means it is in different broadcast domain. So when a broadcast comes to a port, the router will stop. Any layer 2 broadcast is stopped by the router port. That is not the case with the switch. Switch, all ports that are in same VLAN are in single broadcast domain. So when a broadcast packet comes, it will flood. What if it is connected like this? So the flooding comes back here and then goes back here. Again comes back here and goes back here. Again comes back here and goes back here. This forms a loop. Layer 2 environments are subjected to this loop. So there is inbuilt loop prevention mechanism in all vendor switch STP that prevents loop. The spanning tree protocol, the standard classical STP is IEEE 802.1d. This one is default in some vendors. In Cisco also, a modified version of this one is there by default. In Cisco also we have default spanning tree protocol, but it is per VLAN spanning tree protocol. Whereas this one is not per VLAN. This is not per VLAN. That's the difference between Cisco and the other switch which follows only IEEE 2.1d. There will be only one instant of STP for all VLANs. Whereas in Cisco, same IEEE 2.1d but modified to do what? Per VLAN. For every single VLAN, there is going to be a separate copy of IEEE 802.1d protocol. A copy of it. This one is a timer-based spanning tree protocol. That becomes a drawback of this protocol. what is the timer based? For that, we should understand how STP prevents loop. And then we will understand how the timer comes into picture and why the timer is a drawback. Now, loop need to be first of all identified. Only then can be prevented. If two switch needs to prevent loop, first of all they should know that there is a loop. For example, I have two redundant links between these two switch 2. Whenever a layer 2 broadcast packet arrives, it will be sent on all ports, comes back, comes back, goes back, goes back, comes back. It can be DHCP packet or it can be a R packet, any layer 2. This loop will occur. Before this happens, the switches should be aware of this. The switches need to know before this occurs that there is a possibility of loop. How the switches can identify the possibility of loop. In between these links, between the switches, there is a tiny message sent between every 2-second interval, which we call it as bridge protocol data unit. You see, BPD will be sent even between these two. But the PCs cannot send BPDU, but switches will always send BPD. Any device you connect, those devices will receive BPD. The switches are designed to send this tiny packet every 2 seconds on all the ports. Bridge protocol data unit. And this carries information like from which switch this BPD is coming. Means every switch has got a switch ID. We call it as bridge ID. Every switch has got a unique MAC address called a bridge ID. So the switches will send the unique ID along with what VLAN this particular port belong to. If this port is sending, what VLAN that port belong to in that bridge. These two are same VLAN, that's why it is forming loop. If it is different VLAN, they don't form loop. Now, the VLAN info. And also, there is a default priority. All these are sent as bridge ID, the MAC address, the VLAN, the priority, and then the port number from where it is coming out. And then for the port also there is one priority. called port priority. This is switch priority. This is port priority. And then cost for spanning tree, depending on the bandwidth, the cost is automatically determined. Auto. So the cost, STP cost. All these infos are sent in this tiny packet called BPD. This is sent from switch 2 as well as from switch 1. Switch 1 as well as from switch 2. So BPD goes every 2 seconds. Now, when this BPDU arrives, the switch learns it, and then it will forward this BPDU to all. Now, that forwarded BPDU is also forwarded here, and this switch understands, oh, my own BPDU I sent on this port is coming back on this port, which means I need to make the STP work. So they understand that there's a possibility of loop. Before your packet forms a loop, using this BPDU, they not only learn each other, they also learn the possibility of loop. Yeah, they learn the possibility of loop. So, what is the basic building block for STP? It's BPDU. If no BPDU, STP cannot work because there is nothing to relay on for STP. Only depending on this, STP works. Okay. Now, spanning tree protocol, if it is for every single VLAN a separate instance, then it is per VLAN spanning tree, PVSTP. If it is common for all VLANs, then it is IEEE 802.1d spanning tree. This PVSTP is Cisco's. Okay. Now, with BPDU, switch knows that there is chance for loop. How? The BPDU that is sent on this side is just coming back to the same switch but on other port. Likewise, the BPDU that was sent this direction is going back to the same switch 1 but on the other port. So switch 1 knows that between these two ports there are chance of loop. So both the switches are now aware of loop possibility. So they're going to work together to prevent loop. How? By blocking one of the port, they will make a link as a standby. By blocking one of the port, they're going to make one of the link as a standby link. Standby link, meaning In a standby link, no user traffic can go. Now, this is switch 1, this is switch 2. They both know that there is chance of loop. So they have decided to block so that when a packet goes, it won't be sent in this direction because there is a block. When a user traffic goes, it will not be sent. And this switch 2 also knows that the other side is a block, so it won't send anything. But BPDUs are always sent to maintain this loop, maintain this block. How they know that I have to block? With a BPD. BPDUs are still going and coming. That port is not shut. It is not completely shut. It is only shut for the user traffic. The management traffics are still going on. BPD is the management traffic. So to maintain that loop, to maintain that block, it is necessary for BPD to go. So it is blocking. By blocking, this link has become a standby link, a backup link. And this is the active link. Active link, standby link. As you know, standby will become active if this active goes down. This also tells one thing to us, what? If I'll have 2 gig, 1 gig, 1 gig link, I will not be allowed to use all the bandwidth. Only 1 gig you are allowed. The other 1 gig is being blocked in order to prevent loop. This is the drawback of STP. STP prevents loop. Sounds like an advantage. Sounds like an advantage. But it also has got this bad side. You will not be able to utilize all the resources that are available in between. What if I have 4 links? Then it is 4 GB, out of which you will be able to still use only 1 GB. So if you have another 2 more link, even they are going to become standby only. This is the drawback of STP. Though I got 4 GB in between, I'm allowed to use only 1 gig, only 1 link. If that active link goes down, one of this will become active. There are 3 standbys now. One of this will become active. So here we see the very important drawback. It is important today. But few years before, they were not even talking about this point. Few years before, no one was talking about STP as a drawback. Everyone will say STP prevents loop, STP is good. Without STP, there is going to be a loop, all praising only. But after this port channel, virtual port channel, and some other fabric technology, they started speaking the negative side of STP and promoting the port channel stuff, aggregation stuff. You see, that's the need for aggregation. Why do we aggregate? When you aggregate, we call it as port channel, all the links will be active. You will have all 4 gig. When you don't do aggregation, STP is going to allow you only 1 gig for you. Your resources are getting wasted. So after the discovery of aggregation, port channeling, ether channel, people started speaking about the negative side of STP. You will not be able to utilize the bandwidth optimally. So that is our next topic. Let us not get into port channel right now. We'll continue this STP. We saw STP blocks port and makes inactive. Blocks port and makes the link standby. But which port? Because both the switches, as a team, they do this. Switch 1, switch 2. Both of them knows that there is a chance of loop. Let's say here F0/1, here F0/19, here F0/21, F0/5, just random number I have written here. Now this two switch knows that we have to prevent loop because this redundant link will cause loop. They have to find it and they have to do together a cooperative work, a teamwork to prevent loop. So one cannot say I will block here, another cannot say I will block here. What will happen? Both the links can't be used. So there is a procedure so that this won't happen. This two switch follows a checklist to determine who and where to block. They follow a sequence. They follow a sequence of checklist rules. What is that? What is that they follow? First thing is they will decide to pick one switch as a leader, as the designated root switch. Not designated switch, it's a root switch. One of the switches need to be a root switch. How it is elected? That's the first thing they have to do. They have to identify who the root switch will be. That's the very first checklist. Who will be the root switch? For that, they compare their neighbor's BPDU with their own BPDU. Both the switches are sending and receiving BPDU. Switch 1 will compare switch 2's BPDU, and switch 2 will compare switch 1's BPDU with its own. Let us say, for example, this switch has got the priority 8192. This switch has got the default priority 32768. So this is the very first check they do. Who has got lowest priority? The switch with the lowest priority becomes the root switch. So this is the root switch. Lowest priority. The switch with the lowest priority is the root switch. Small priority, listen, very important. It's not OSPF. OSPF, high priority, it's opposite. Spanning tree, what is the spelling for spanning tree? S-P. S is also spelling for small. At least like that you can remember. Should not have confusion. Spanning tree, is it big priority or large priority or small priority? It is only small because spanning tree spelling is S, small spelling is S. S-M-A-L. That is how we can remember if we are confused, to avoid confusion. Okay, small priority, but the default priority is 32768 on all the switches. On all the switches, this is the priority. 32768 plus the VLAN number. Let us say we are talking about VLAN 1. Both the links are in VLAN 1, which means 32769, 8193. That's the priority of this switch for VLAN 1 and 32768, 9 for VLAN 1. I told you Cisco follows per VLAN spanning tree. In the IEEE 802.1d, this is not at all considered. This is the priority. Okay, now per VLAN spanning tree protocol. The one with the lower priority becomes the root switch, and the root switch ports will not block. Root switch ports are called as designated forwarding port. Both the ports are designated forwarding. They are not supposed to block because they are root. See, if one of the branch blocks, what will happen? The water won't go from the root. The root should not block. That's the base. So the ports towards switch 2 are in forwarding state. So out of 4 ports, we have already finished 50-50 job. Already these two switches know that switch 1 is not going to block, only switch 2 have to block. They already know who's supposed to block now. Without any confusion, now they can easily decide the blocking spot. That's why this checklist is needed, so that both will not block. Switch 1 say I will block here, switch 2 say I will block here, and no one will be able to forward any traffic between these two switches. Not good. To avoid that, this STP first step, what it does, it elects the root switch so that the blocking responsibility switch will be identified. Switch 2 is the one which has got the responsibility to block. Okay, what is next? Switch 2 will now try to find whether to block switch F05 or F019. Switch 2 will now find some reason to block one of this port. What it will do is, first the switch 2 will see which link has got more bandwidth so that I can take the link with low bandwidth to block. For example, if the bandwidth is here 1 gig and here it is fast internet 100 meg, then there is a reason for switch 2 to say I will block this and I'll use this. This is 100 meg, this is 1000 meg, which is 1 gig. But in our case, it is not, because both are fast internet. Which one should I block? When the speed is same, the STP cost will also be same. 19 is the default STP cost for 100 meg. This is all predefined. If you have 100 meg, 19. If you have 1 gig, 4. This is predefined. All right. If you have 10 meg, 100 is the cost. This is all predefined. If you have 4 gig, 2 is the cost. All right, these are all predefined values. Now let us go with this one because we got only fast internet. Both sides, because the bandwidth is same, the cost to reach the root switch is also same. If I would have had 1000 here, then cost would have been 4, so this will go blocking. Cheaper cost to reach the root switch, so this will become a root port. What is a root port? The port that connects to the root switch is a root port. Whereas this one is the blocking port. But in our case, we have the same bandwidth on both the sides. It's the same bandwidth on both sides. So what do they do? if the bandwidths are same. They compare the incoming port cost. See, this guy is sending BPDU with a port cost of 128.21. This 21 is copied from here. This guy is sending with a port cost of, it says, hey, my port cost is 128.1. Now, switch 2 will compare the port cost and say the one with the lower number I like. So this will become the root port. And this one is bigger than 128.1. So this will become blocking port. Did you understand how the blocking port is decided between these two switches? So we have taken two switches, switch A and switch B. Only the host name is configured, nothing else. Switch A and switch B. Now we are going to connect cables. I'll connect between 1 and 21 and the opposite here, 21 on top and 1 here. So for a very easy reference, I want this to be visible properly. Okay, this is okay. We can see the top one is 21.1, below one is 1.1. Now I want switch A to come this side. All right. Okay, so now what I'll do is I'll take a snip of this. Now what do you see? This one is small port, whereas here the below one is the small port. So the port priority for this will be 128.1. It will be 128.21. Whereas here the upper one will be 128.1. The below one will be 128.21. Okay. Now, in our early example, the priority one was having small priority, the other one was having 32768. But in reality, by default, all the switches will have same priority 32768. In our case, we discussed using 8192 as a priority of switch 1. But by default, it will not be 8192. By default, this and this both have got same priority 32768. 32768 plus 1, the VLAN number 32769. Both have got same priority. In that case, what will happen? In that case, in the bridge ID, they also have a MAC address. The bridge ID, in the BPDU, when they send the bridge ID, they also have a MAC address in it other than the priority. So when there is a tie in VLAN number is 1 for this also 1. Priority is a tie. So what they do is they now compare the MAC address. Let's say the MAC address of this is AAA and MAC address of this is BBB. Which will become the root switch? This will become the root switch. Let us now go back and see what is the real MAC address of the switch, and then we write it down here. Select all, copy, put it in the paint. I want to know the MAC address of switch A. How do we know? Very simple. You type show spanning tree. Show spanning tree, and you only copy the MAC address which is under the root bridge, not this one. Don't copy the root ID. This is the bridge, switch A's MAC address. You see the priority 32768 plus the VLAN number 1, 32769. Now let's copy this. This is the MAC address of this switch. And I'll put it here. And now the MAC address of the other switch. Show spanning tree. Copy the MAC address of this one and put it here. Okay. Now both the switches will compare the MAC address. Spanning tree, I said small, not only for the priority. For any decision, it will only pick the smallest one. Even the MAC address. Which switch's MAC address is smaller? Can anyone say? Switch B's MAC address is smaller because here you got 1, here it is 7. So this is the root switch now. Let's go verify that. Switch B. Yeah, it says I'm the root switch. So this MAC address and this MAC address will be same. This is the information about the root switch. Because the switch itself is the root switch. Because this switch itself is a root switch, you see the same MAC address above under the root ID, also the bridge ID. Whereas on the other switch, this is the MAC address of the root switch, and this is the MAC address of the local. Right? That's why I say not to copy this. This is the root switch MAC address. Okay. Now on the root switch, you see this one, this bridge is a root. Whereas on the other switch, what you see, it says the root switch is connected via 21. Because 21 port is the forwarding port, the other one is blocking. We'll come to this one later. Now let's go back. The root switch will have this clear notification for you. I also told you the root switch will not block. They are designated to forward. And I also told you the priority 128.21. That's the port priority because the port is 21. This is 128.1. See? So this is it. They have this priority. 128.21, 120.1, which I have written here. 128.1, 120.21. Fine. What is the cost? Cost is 1919. You can see that one also. All right. Now, on the other switch, the blocking need to happen. So what they do is they compare the incoming port priority. The incoming port priority is 21 here, whereas the incoming here is 1. Which one is smaller? 128.1 is smaller. So this is forwarding. 0/21 is forwarding. This is big, so this is blocking. 1 is blocking. Let's go see. 1 should block on switch A. Yeah, 1 is blocking because the incoming is bigger. Incoming matters, not the local. It won't compare the local. It will compare the incoming port priority. This is forwarding. And now you see the role is root port. What is the root port? The port that connects to the root switch. That's the root port. Blocking port is an alternate port. On the root switch, you will not see root port. Instead, you see designated ports. On the root switch, you see designated root. Root port will be seen only on the opposite switches, not on the root switch. Root ports are the port that connects to the root switch. Are you clear with the blocking? How this is blocking? The incoming to this F01 is 128.21. 128.21. 128.21 is big, so 120.1 it likes, so it keeps for forwarding. Is this clear? All right then. We will continue